Zoom recording. All right. So white background here. A lot of people aren't joining anymore. I don't know how many people dropped off the class, but Kubernetes seemed to be really, I don't know, but it seems to be kicking some butts. But I'm just gonna continue teaching anyway until the class is over.
Probably you find a Linux role, not necessarily Kubernetes.
Huh?
Probably they got some Linux role.
Linux problem?
I mean, probably they got a job with the Linux skills they have already.
I highly doubt it.
They mustn't have DevOps skills, right?
I highly doubt that. But if they do, I'm glad for them, you know. But if you don't, you should be in the class. So yeah, today we're going to talk the same thing we were talking about on Thursday, right? About volumes. And we're going to try to create the volumes with the persistent volume claims and, you know, claim those volumes using parts and stuff. Easy stuff. If you remember, if you remember like the steps, then it's easy stuff. So step one is to create a volume. Just put step like 1 is volume. That's step 1. So here we already know how to create a volume, right? This is maybe LVM or something. This could be inside a virtual machine running somewhere like a virtual box. Linux VM in virtual box, right? VM in VBox. All right. So this is step 1. You have your virtual box. You create your virtual machine. So 1, 2, 3. Man, this thing is not easy to use. All right. So step 1. Let's put it here. Let me cancel that and do it the other way around. Say create volume. Oh, nice. That's nice. Create volume. All right. Step 1. Create volume. So to create your volume first, you need your maybe virtual box wherever you're creating it. So 1 is going to be VBox. The pen I'm using, guys, it sucks. VBox. And then number 2, you need to create a virtual machine on that virtual box, maybe CentOS box or something, or maybe CentOS machine. So CentOS VM. And then 3, you create your logical volume. And then step 4, you mount that volume. And then number 5, you create an NFS share. To share the volume or share the mount, right? So step 5 is to share the mount from step 4. Step 4 is to mount step 3, the LVM on step 3. Step 3 is a volume that you create inside your CentOS virtual machine, whatever. And then step 2 is a virtual machine you created in VirtualBox. And then step 1 is you get your VirtualBox from somewhere. So these are the 5 steps that you follow to get a volume. All right. Now we're going to move on to a second page or something. I don't know how to use this stuff very well. Just go home, save that. Okay, start drawing again. Not now. So now, after we have our volume, all right? That first 1 to 5, that was just for step 1 in the process of what we're going to do in the class today. The second thing we have to do is to create a YAML file. This now is inside Kubernetes. We want to use the volume that we created inside Kubernetes. So
LVM stands for logical volume?
Yes.
Okay.
Mm-hmm. So now we want to use the volume we created in step 1. We want to use that inside whatever, Kubernetes. So first, to use volumes like that, external volumes, we call them external volumes, right? Because Kubernetes didn't create them. It's not an empty div volume that was created by Kubernetes itself, that was created inside a pod. This is an external volume that was created somewhere else, maybe on a cloud, or maybe inside AWS or EBS volume in AWS, or a Google Cloud persistent volume, or any kind of volume, or NFS, just like the one we're going to create today, an NFS volume. It's an external volume. You want to use an external volume on your Kubernetes cluster. The second thing you do after you create that external volume is you create a PV. Now, why is this thing looking like this?
The PV mean persistent volume.
Michael, I don't know. There's something wrong with your microphone. It's like, it's really, the noise is really
A lot of interference.
Yeah. So second thing you want to do is you want to create a persistent volume. Number 2, persistent. And the pen is really bad. Persistent. All right, so this is just going to be a YAML file. The YAML file is just going to, which is a YAML file. That's all it is. All right, and in that YAML file, it contains information from the external volume. All right, YAML file containing info from the external volume. All right, and what's that info? It is like, say, the size of the volume, the address, the server address where that volume is coming from, right? So number 1, volume address or volume info, such as address. Same thing, size. You know, some random things that you need for the information about that volume. Let's say the mount point, right? Where the share that you're exporting, right? So when you've already mounted it, say you mounted it on /DevOps, that means the share that you're about to share over the network for Kubernetes to pick is going to be slash DevOps, right? So the path, that's called the path or something. So this is what you're going to share over the network for Kubernetes to see, oh, okay, this volume is coming from this server. It's 5 gigs. It's mounted on /share, something like that. And then it's going to pick it up, right? But those are the things that you need. All right, then after we have this, is this making any sense to anybody? I know the handwriting is like crazy, but the pen I'm using is really hard to use it very well.
It's like a config file for the volume.
Yep. All right. So I'm just giving you information, what what that file will, the necessities, what the file needs to have to understand, where the volume is coming from. So the file needs to understand exactly how you specified or how you created that volume. And now that it's about to mount it onto onto the Kubernetes cluster, these are the information it gets to be able to do that. So is this making sense? Just need to know before I move on to the third. All right, so I'm going to assume that this made sense. So I'm going to save this, save that drawing. Guys, this is crazy. But that's going to come a couple of times. So
And it takes way longer than 5 weeks.
it's gonna come a couple of times when you're doing free trial and stuff. Yeah, it's gonna happen. Okay, so go back to home. Don't save. Just start drawing a new one. All right. This is a third one. So the third thing in the process is going to be, let's see. All right, not bad. Reduce that just a little bit more. Okay. So the third thing is going to be to create a persistent volume claim, PVC. Persistent volume. I'm trying as hard as I can with this pen, persistent volume.
So the first thing you do is create the volume, then you create the PV, the persistent volume parameters, and then you create the persistent volume claim.
Yep. So persistent volume claim is going to all this does is it says, well, since now you've mounted an external volume, there's an external volume that you've created. Now I'm going to bind to it, right? I'm going to bind to this persistent volume that you've created, right? And its own function is only to make itself available to whichever part is going to claim the persistent volume claim, all right? That's its only use. It's just a specification that says that, okay, well, now there's a volume available here inside the cluster. And people are going to be looking for this volume. People are going to need space. So I'm going to create a claim that if you claim me, if anybody who is looking for space, if they see me, then they can claim me, right? So if a pod is looking for volume space, and then they see me as a persistent volume claim, then they can just claim me, right? And I'm going to give them all the information about the persistent volume, right? So it's like the middleman. It just plays middleman between the volume and whoever wants to claim that volume, okay? The pods are the ones that go and claim the volume. So he is just a middleman saying, well, a volume exists. You're a pod that needs a volume. Okay, I know everything I need to know about that specific volume. So you go through me before you get to the volume. So I don't know exactly how to explain him, but I'm just going to call him middleman. who has information about the volumes, middleman. So number 3, we're going to create a middleman, which is a YAML file. Okay. Right. So middleman, that stands in front of, it goes to part, and on the other side, on this side, from the middleman on this side, there's a, on the left side, there is a PV. On the right side, there's a part. Makes sense, right?
Like a proxy.
Yeah, so it's a proxy.
Oh, okay.
So on the left side, the persistent volume. On the right side, a part that claims the persistent volume, right? All right. So that's the third thing. And then the last thing is going to be, who can guess the last thing?
Ports.
Exactly. The last thing is going to be the parts, right? So we already know how to create parts and even create a part that needs a volume. So this class isn't even going to be long because we have this thing I was writing on to demo the whole concept, and then I just go in and create it. Leave the rest to you with the homework. You do the same thing, all right? But as long as it makes sense to you, the processes, okay? I was on YouTube trying to research how to get this done, but there isn't like really anything that is showing that we can use for mini cube. It's either you have like a Google Cloud or AWS, some kind of cloud. Everybody wants to teach it on cloud. They forgot that people still have like NFS and stuff like that. So because we're doing this, because we have like a mini shift, or is it mini cube right now, then we'll have to use something local. Okay, we don't have clouds. Yes.
It's possible we can use AWS free tiers to do this, right?
Please, let's just do the class and go. We'll get to that point. All right. That's exactly how it's supposed to. The class is supposed to be. When we create when we get to the do Kubernetes part, when we're building our cluster, we'll choose where we want to build the cluster, and we can now start using the persistent volumes that they have over there. All right. But for now, we don't want to use any free tier. We don't want to jump ahead of the class. We just want to go according to how the class is structured. Can we do that?
Yeah, sure.
All right, so I'm going to save this one, and I'm going to go back home and start drawing again the next one. So parts. Okay, so this is for the video. All of this is just for the video. So when you want to watch the video, you come back here and just get the stuff done. Yeah, okay. So, part, which is a YAML file. That file that needs, or YAML file for containers that need volume, for containers that need volume. So that's it. Now let's get in and start creating stuff, all right? So enough with the iPad and the bat writing, and now the doing. All right, class is not going to be so long today because I want you guys to spend some time actually working, doing this stuff. Kubernetes is one of those hard things, and it needs a lot of work. You need to constantly be working on it. All right. So today, not just tomorrow. All right, guys. So Let me see who is participating today. I haven't even seen. We have 10 people. Gabby, iPhone, Mega Boy, Green, okay. So okay, so I already have like a couple of configurations that I need to create mine, but I'll show you exactly how you can go about to get the stuff for yours. But first, let's create our volume. Let's first create the volume and stuff. So we already know how to create volumes, right? First thing, I'll just like start my Kubernetes cluster here and try to create a volume on the Kubernetes cluster itself. Power this one off. Let's power off. I want to power off the compressor. All right, so guys, what I want to do is create some kind of volume. You already know how to create. I'm pretty sure everybody here knows how to create a volume. I'm going to use my Minikube virtual machines to do that on. So first thing is first, settings and storage, right? In SATA, we want to add SDB1. Yeah, that's how you do it. Create new disk. Continue there. 8 gigabytes. I want to use maybe 10 gigabytes. 8. So this is going to be SDB1, right? Okay. And I'm going to start Minikube again. Start. Keep running, so it's back on. Hopefully I didn't mess up my cluster by doing that. It's taking a long time. All right, let me see. Minikube cluster. Sorry, that's kubectl cluster info. My fault. All right, so it looks like I have the cluster running. So now I want to go into Minishift and configure that volume that I just Minikube and configure that volume. Minikube SSH. All right. Let's see. cd/def. What's in there? Do I have SDB1 or SDB? Let's see. SDB. All right, looks like I do have SDB. So fdisk as usual, fdisk/def SDB. Okay. Permission denied. Okay, sudo -i, and then fdisk/def SDB. Okay, we're in there, and we want a new one. So that was N primary. Yep. Partition 1. Yep. First sector. Just here, I just press enter for everything. Right. Last sector, everything. So the whole 10 gigs has been assigned. I want to change the type to a Linux volume. T and L. Volume is supposed to be Linux volume, LVM, not just Linux volume. Is DF. Where's Linux volume? E, yeah. Okay, so it's 8E. All right, so Linux LVM, that's good. Now we want to print the partition table to see if it's in there. Okay, so it is. And we want to write and exit that. Next thing we want to do is part probe, right? Part probe /def /SDB SDB1. All right, okay. I can't do that, I guess. So it's already been written. Right, so just part probe. Okay, now let's PV create, and whatever we do, PV create /def SDB1, right? Because that's a partition. It created that. Now VG, we want to create a VG. Let's say PV display. Okay, we have that. PV doesn't even have a name, but let's create a VG create. We want to call this persistent volume. It's also PV for, okay, let's see, VG PV. Volume group for persistent volume. No, I'll just say Kubernetes volume group, right? Kube VG, and then that would be /def SDB1. Okay, it created it, and then we want to create a logical volume. All right, so first we do VG display. VG display. Okay. So I think it's VG create -L. Want to use the physical extents and stuff. How do you create volume using the physical extents? Let's see. LVM using PVC. As for one thing, they just had to show me every single thing. VG display, I'm trying to, okay. All right, look like here it is. Okay, I'll copy this. Copy, that's all I was looking for. Paste LV, create dash L, extent size, right? It says extent size. So the extent size is right somewhere. Let's see. Free PE, right? PE's physical extent size is only 250. Total PE two.
This is 4.
2,500.
All right. So paste that.
It says PE size for MIB too. If you go
right.
up to
Allocate. You see what it says? Allocate is 0, right? So free PE. You're trying to use the free PE. This is the one that's already been taken.
Okay.
So we want to call it. What do you want to call it? Kube LV. Kube LV. All right. And then the volume group, I think, right? Kube VG. From Kube VG. Let's see. Oh, created. So that's good. Let's do a LV display. LV display. So we have the LV and it's right. It used the entire 10 gigabytes that we provisioned. So that's good. Now BLKID. We don't have that. We have one here, but we don't have, how do you call it? File system type. So we have to make the file system type, which is make fs -t. We want to use ext for, and that's going to be /dev mapper kube vg, the one we just created is right here. Copy that, paste, and it looks like it created that too. Now we have to mount it in the FS tab. So we do, we just copy, let's do BLKID again, BLKID, and we copy this, or we can copy this. Doesn't really matter which one, but I'll copy this one. Copy, VI/SC FS tab, and I'm just gonna paste that down here. And where are we going to mount it? We're just following the same, just like here. We're mounting it in slash, what do I think? I'll call it kube vol. And the type was ext4. So this third thing here is ext4. ext4, because that's what we chose to create when we just created, right here we said make fs-t ext4, so we created ext4. We just want defaults. Copy that and paste it. And the third part is that part is 0, 0. All right, so we want to mount -a. Okay, I didn't create that, so I'll just make there /vol and mount -a. So df-h to see if I have that, and I do have it. Okay, so the next thing I want to do is share this over NFS. All right, there's something xt exports. So I'll just vi into exports. First, I'll get the IP address of this server, which is IPS, right? So I want to export it over the network, and the IP address is here. I'll just copy that, and vi into the etc exports. So you want to export kubevol. Insert. What we're exporting is kubevol and the IP address for what we are exporting, and we want it as a read write, right? We also want that as let's just go see. I did a bit of research. Not this. Not this. Yeah, sync. Yeah, thank you. How did you know? What I was doing is like you were in my head.
NFS, I know.
Oh, you know NFS? Okay, that's good. Sync. We want to sync it. I mean, there are other options that I want to have, like no root squashing. I don't want it to squash root users and stuff like that. This is like a little too much, but it looks okay here. I'll just copy the stuff that's inside here. No subtree, no root squash. I don't see root squash here. But you see the format is the same. First, what you're trying to export, and then the IP address, and then, you know, all of this, whatever. But I'll just paste that in there. For this ID, I just want it 0. I just take that part out, you know, but no subtree check, that too is important. All right, so with that, the next thing I want to do is to, wait, did I just like export /vol? That's the exact one that is using in the mount.
Yeah.
So I'll have to make a new one. Make there slash cube NFS. Thank you. All right, and instead that's the one I should be exporting. I'll export cube NFS instead. All right, so let me think about it for a minute. If what I should be exporting is kubevol. No, don't worry about this. It's kubevol. That's what I should be exporting because that's what's mounted. That's what has the volume. What am I even thinking? So kubevol, right? Okay, so let's export or restart NFS. So service, or is it system CTL? System CTL restart NFS server. Okay, it restarted. Export FS. See what I want to dash RAV. All right, so it's showing me that it's actually exporting that now. So if I try to show exports or show mount. Let's see, show mount dash E for this server here. Copy that, paste. So it's showing me that it's exporting that over the network, right? So this volume is available over the network for whoever wants to pick it up, they can pick it up. Let's look at my Kubernetes. Terminate that process. Shell, new tab. So this is my local Kubernetes. Okay, let's show mount dash E. So you can actually see it too. So it's actually exporting it over the network, right? Because right here, I'm inside my Kubernetes cluster. Right here, I'm on localhost. So therefore, if this is picking up that mount, that means it's over the network, it's exposing it. Now we want to make sure, so we're done with the first part. We're done with the first part, which was the NFS volume, the logical volume, the NFS share. We're done with that first part. Second part is to use Kubernetes to create a persistent volume. So it absorbs that amount, kube volume, all right? So class isn't even gonna be long today. As long as we get all this and get it working, then I'll just put it out as a homework and then you do it. All right, so I got the explanation from the first part, explaining the steps. That was really helpful. I should have been doing that from start. So now let me look. In fact, it's in here. Let me look. So I have volume. I have what else do I have? PV, and I have PVC. That's what I want to use, but I want to show you how you can go about creating your own PV and your own PVC. All right. First things first, let me first delete whatever I've created. Let me delete this PV, delete the PVC. So kubectl, delete PV. I have a PV called PV1, so it's deleted. Let me delete the persistent volume claim. You can't delete it if I haven't even deleted the persistent volume claim. So I'll delete the persistent volume claim, the middleman. PVC from PVC1, okay. Now I want to delete the parts and stuff. kubectl, delete all. So that's going to delete my part, the service, whatever. That's fine. So I have a clean environment and then we can work inside. That's just taking a little bit of time, but don't worry. It will.
While waiting,
Mhm.
did you already install NFS before using it? Or we
Oh,
don't need to
okay.
using Minikube?
No, I mean, I didn't bother asking you to go and create a new virtual machine to install your volume on that. I just used the Kubernetes cluster virtual machine that's already running. I just use that one, you know, because it already has the stuff installed in it. I didn't want you guys to go and start failing and then class is just long for no reason. So I just use what's already available, what's running. Because if you think of it, if we start creating new virtual machines, your computer is just going to be slow and then class is just going to be long for no reason, right? So just use Kubernetes Minikube, right? Minikube SSH, go into that cluster, or first you have to stop it like I did, right? You first stop it and then you add a volume to it, right? You attach a volume to it and then you configure that volume and then you mount that volume, whatever you want to do it, you know. So everything is already installed in it. You don't need to install anything. But if you want to do your own, I know you are the man who always go and do the extra stuff. You get the concept, take it, create your own virtual machine, create the volume on that virtual machine, export that volume over the network, and then that's the same thing, you know. It's the same thing. It's no difference. Then let Kubernetes pick it up and use it. But then you have to install all the other stuff you're talking about. Okay, so it looks like it came back. Everything has been deleted. kubectl, get all. Class is very fast today, guys. I don't have anything. What was that?
Gracious.
Oh, okay. Gracious. He's always doing some weird stuff in the background. Anyway, since we have nothing ls, we want to go to the Kubernetes documentations. Do I have it? Let's just go to kube.io. Even in the exam, this is going to save your life, the documentation, kubernetes.io. Okay, so we want to create, first of all, we want to create a persistent volume. The documentation will show us how. Persistent volume. My internet connection is unstable. What? All right, so just scroll down. Just look at the YAML file for persistent volume. These all looks funny to me, but yeah, there goes one right here. This is a pod. We don't want that pod. We just want a persistent volume. This is another pod. Persistent volumes, yeah. Okay. Just keep looking at pods and stuff. All right, here's one. Okay, persistent volume, here's one. So just copy it. You see, it says persistent volume. So just copy this and then we can remove what's not supposed to be on. But I think everything that's here should be on. Anyway, let's go try to use it. So vi test pv dot YAML test pv dot YML. In there, I'm just going to paste it. Okay, kind is persistent volume. I want to call it test pv And capacity is 10 gigs, right? From the one that we created was 10 gigs.
Prof, please, can you pause? Can you, like we do, see one eye is passed, like stop and we record again as we usually do.
Okay. Yeah, thanks for reminding me. Sometimes I just keep going. So resume recording, then stop it.